lesson on graphical transformations, and we're just going to start with a problem today, and this says f of x equals x squared, graph negative f of x plus 3. All right? And so when we go about doing this problem, we need to just start out by listing the transformations. Okay. So the first part here, you have a negative f of x, so that is a reflection over the x-axis. Okay, so reflecting it in the vertical direction, and that's over the x-axis. And then the plus 3 here, and then the plus 3 here means a shift up of 3. Okay, so reflect over the x-axis and then shift it up 3 units. And really there are two ways we can see this, and so the question is which transformation do we do first? Okay, so between reflecting over the x-axis and shifting up 3, which do we do first? Well, let's check both. Okay, so let's pretend that we reflect first and see what that looks like, and then we'll take another graph where we shift up first and see what that looks like. So if you look at the original function f of x equals x squared, then the graph of this is just a parabola with a vertex at 0, 0. And so if we were to reflect it first, this parabola would get flipped this way, and then we moved it up 3 units. So it would look like this. Okay. And then if you were to shift it up first, sorry for moving this paper around too much, take this point here, if you were to shift it up 3 units and then reflect the whole thing over the x-axis, then you would get something that looks like this. And I'm sketching this, but it is also very accurate and true. Okay, and so clearly it makes a difference, and what we want to know is, well, which one is the right one? Now luckily in this example, because we have an actual equation for the function, we can actually apply this rule to this particular function and see what happens. So this is going to be negative x squared plus 3. Okay. And if you were to graph this in your calculator, let me do that now. Alright, and you can see here from this example, this graph that I have here, that the first choice here, reflecting first, is the correct thing to do. So we definitely want to reflect first in this case. Okay. Now, you know, a good question that we often ask in math is that once we do an example of something, can we do that for every single example? And so let's look at another example and see if the same rules will apply. So here we have another problem that says g of x is equal to square root of x, graph g of 2 minus x. Okay? And just for reference, the square root of x is something that looks like that. Okay, some teachers call that the shooting star graph. Okay. And then we're supposed to graph what this looks like. So let's again list out the transformations. And another way you can look at this function is that it's really g of negative x plus 2. Okay, g of negative x plus 2. Okay. So this is a reflection over the y-axis. Over the y-axis, and then shifting to the left 2. And we're faced with the same question as before: which transformation do we do first? Which transformation is done first? So let's look at the two examples. What if we reflect first? Okay. So if we take the original picture and we reflect it over the y-axis first, it would look something like that. And then we shifted 2 to the left, then it would look something like this. So this would be a negative 2, and it will go in this direction. Sorry, writing off the screen there. And then what if we were to shift first? So we were to shift 2 left, then we would have this image, and then reflect it, well, we would have this image right here. Okay, so shifting it 2 left gives you me like the first darkened red curve here, and then flipping this over the y-axis gives me the curve that points in the other direction. So you'd have an x-intercept here at 2, and then it would go in this direction. Okay, and once again, clearly these two are not the same graph. One of them is the right answer. Function in my calculator, square root of x minus 2, and when I graph it, this is the graph that I get. Just so that we know where this comes from, g of negative x plus 2 is just the square root function, and then we're going to substitute this part in here. Okay, so we're going to substitute 2 minus x in here for x. So, or negative x plus 2, same thing, negative x plus 2. Okay, and so from this graph we can see clearly that shifting first is the way to go in this case. Alright, and if you just compare this to our last example where we talked about, well, in the other example we actually had to reflect first. Okay, so this is example 1 when we had a negative f of x plus 3, and the example 2 where we have g of 2 minus x, or g of negative x plus 2. So it seems that in some cases we reflect first, and in some cases that we shift first. So the general concept here is that for the vertical translations, or for the vertical transformations, we want to do reflect and stretching before shifting. So for example, if you had a function like 3f of x minus 2, this is also a stretch. Okay, so we're going to do the stretching before we do the shifting. Or if you did negative 3f of x plus 2, here this is a stretch and a reflection, but we need to do this part here before we do the addition and subtraction. So you can almost say this is the follow, order of operations. Okay. The second general rule is for us to, for horizontal transformations, we want to shift before we do reflecting and stretching. So for example, in this case here, we would want to do the shifting here first, so shift this part first before we do the stretching and shrinking. Okay. Also, we did in the other example, what we saw was negative x plus 2, so we actually wanted to shift this part first before we actually did any of the reflection. Okay, and this goes along with the similar concept of that anything you do with the input or anything you do with the horizontal transformations, it is counterintuitive. It is counterintuitive. Adding actually moves left, subtracting actually moves right, and if you think about order of operations, you actually want to follow reverse order of operations. Reverse the order of operations. Okay. And so the two examples that we've done here sort of give us a sense of what happens when we mix transformations. In the next video, we'll talk about what happens when we mix horizontal and vertical transformations. Thank you for watching. Have a wonderful day. As always, if you have questions, ask your teacher.